the first part of dividing complex numbers that we have to look at before we go further is we have to make sure that we are comfortable with conjugates. So conjugates are just taking a complex number. If the complex number is A plus BI, right, Tatiana? Goodness gracious. Tatiana. TY. Right? Okay. I said TA. Sorry. It was a brain fart. Bahanglaise. Let's move on. All right. A plus BI, the conjugate has the opposite sign, and it's in the middle, A minus BI. So if this one had 5 minus 3i, then the conjugate would be 5 plus 3i. And we just want to make sure that we can FOIL those out and get an answer for it and just see what happens. Because when we do dividing complex numbers, that's what we're going to be doing, is we're going to end up taking something and multiplying by the conjugate. So if we FOIL these out, we get 5 times 5 is 25. And then what else do we get? We get 15i. 5 times 3i is 15i. And then what else? We get negative 3 times 5 is negative 15i. And then what else do we get? Negative 9i squared. So what happens to the middle terms? They cancel, and that's going to happen every single time with the conjugate. The middle terms are going to cancel because they're going to be opposite signs of each other. That's what the conjugate does. And then over here on the end, we have an I squared, and so what is that going to do? It's going to be a positive 9. Okay, so if we have a 25 and a positive 9, then what do we have? 34. Okay, so 34. So if you multiply complex conjugates, your answer is a real number. You get a real number. That's important. Okay, so can somebody remind me from day before yesterday, what is an I? What does I represent? Imaginary. And in terms of like the number definition, if we flip this over, what is I actually? Like as a number, what does it represent? Square root of a negative or square root of negative 1. So I represents a square root. And if we were to have a fraction, are you technically allowed to have a square root on the bottom of a fraction? No. So are we allowed to have an I on the bottom of a fraction? No. So the way that we get rid of an I on the bottom of a fraction is we multiply the bottom of the fraction by the conjugate. Because if you multiply by the conjugate, you don't actually get an I, you get rid of all the I's, you get just a whole number. Does that make sense? If you multiply by the conjugate, you get rid of I's. That's how conjugates work. Now, if we were to take this problem and multiply by the conjugate on the bottom, that's great. It's going to get rid of the I, but it's not going to keep the fraction an equivalent value. For us to keep that fraction as an equivalent value, we have to multiply by the conjugate on the bottom of the fraction and the top of the fraction. That way, we're changing what the fraction looks like, but we're not changing the value that the fraction represents if we multiply the same thing on the top and the bottom. Does that make sense? So if we're going to divide complex numbers and we have an I on the bottom of the fraction, this is all that you're going to do if you have the I on the bottom of the fraction, then we multiply by the conjugate on the top and the bottom. So we have a complex fraction times a complex fraction. How do you multiply two complex numbers? Complex number times a complex number. What's the process for multiplying those? Right, you go across, and so we're going to FOIL those. The two on the top, we're going to FOIL the top, and then for across the bottom, we're going to be FOILing those as well. So if you look at the example problem, you can see in the work that that's all they've done next, is they've FOILed these problems. FOILed the top, 7 times 2 is 14, 7 times 3i is 21i, negative 6 times 2 is negative 12i, negative 6 times positive 3 is negative 18i squared, and they did negative 18 times negative 1. And then they FOILed the bottom, they did the conjugate, and showed that work. Does that make sense? Okay. So, and then they simplified it, they combined their like terms and all of that. So let's go ahead and let's move down to example 5 so we can see how this would work. So if we wanted to get rid of the I on the bottom of the fraction for problem 5, because having an I on the bottom is not proper, then what should we multiply by? The conjugate, which is 2 minus 4i, and we're going to multiply by that on the bottom and the top because we want to change the way that the fraction looks, but we don't want to change its value. So when you multiply by something on the bottom and the top, this is like multiplying it by 1. Because something that's the same on the bottom and the top is 1. So I'm going to change what this looks like, but I'm not going to change the value of it because I'm multiplying it by 1. Okay, so let's go ahead and FOIL the top. What do we get when we FOIL the top? 3 times 2 is 6, and then we get 3 times negative 4i, negative 12i. And then we get 5i times 2, 10i. And then we get 5i times negative 4i. Okay. And then on the bottom, we have 2 times 2 is 4. 2 times negative 4i, negative 8i. 4i times 2. Positive 8i, and then positive 4i times negative 4i, negative 16i squared. All right, so what happens with this? So that's a 20, right? And then with the 6, that's a 26, okay? What about this part right here? That's a positive 16, okay? So 4 and 16 is 20, okay? The negative 8i and the positive 8i cancel. And then what about these two? Negative 2i, okay. So we multiplied by the conjugates, and then all we had to do is FOIL everything out, and then at that point you're just combining like terms. Now, if we look at what is left over, what do you notice about all of these numbers? You can divide by 2. They're all even numbers. So 26 divided by 2, 2 divided by 2, 1. 20 divided by 2, 10. So our final answer is 13 minus 1i over 10. Okay. How do we feel about that? Make sense? Yeah. Okay. Let's try the next one. What should we multiply by? 6 plus 2i over 6 plus 2i, okay? And then let's go ahead and go through the process of FOILing. So what do we get on the top? 48 plus 16i plus 12, nope, 36i plus 12i squared, okay? And then what do we get on the bottom? 36 plus 12i minus 12i minus 4i squared. Okay. So the positive and the negative 12 cancel. Positive 12i squared is negative 12. Negative 4i squared is positive 4. Okay. So 48 and negative 12. 36. 16i and 36i is 52i. 36 and 4, 40. Okay. These are even numbers. Are they divisible by more than just 2? Yeah? What are they divisible by? 4? Are they divisible by more than 4? Anybody know? Are they divisible? No. Okay, so let's try 4 first. So divided by 4 is 9. Divided by 4 is 10. Divided by 4 is 13? Okay. Okay, so they're not divided by more than 4. So 9 plus 13i over 10. Okay. Okay, this does not have all the types of problems, so there are some problems that might be a little bit simpler. So I'm going to add just a couple examples that are more simple, just in case you see some of those. So we're going to add example 7. Let's say we had 3 minus 2i divided by 5i. 3 minus 2i divided by 5i. So you know you can't have the I on the bottom, right? How do you think you could fix that? So think it through, because this case doesn't need a conjugate. It just needs to not have an I on the bottom. So how could you multiply by something to make it so the I on the bottom would no longer be an I on the bottom? If it's just an I, it's going to be an I, right? If it's an I squared, it's no longer an I, right? It becomes a negative 1. So if we do another I on the bottom, that'll fix it. So if you have a more simple problem, you don't even have to worry about the conjugate idea. You don't have to worry about changing signs. You can just multiply by I on the top and the bottom. It will fix itself. Okay, so if we multiply by I on the top, what do we get? Okay, over, and what do we have on the bottom? We have 5i squared, which is negative 5. Okay, so 5i squared, this is negative 5. The negative 2i squared is what? Positive 2. Okay, so this is really I times 3. So I just took this I and I was distributing it. Yep. So what order should we write these in? 2 plus 3i over negative 5. Do most mathematicians leave a negative on the bottom of a fraction? No. So how could we fix this answer? Should we leave the negative down there? Yeah, so I'm going to take the negative. I'm just going to move it to the top. So I'll leave the 5 positive on the bottom. I'm going to move it to the top. And if I take the negative and move it to the top, what's going to happen to the top? Negative 2 minus 3i. Now, this answer was not wrong, but if you were doing multiple choice problems, it never would have shown up, because mathematicians don't typically leave negatives on the bottom of a fraction. They usually put them on the top. Make sense? Okay, not wrong. It's not wrong. You'd be right. But if you were doing a multiple choice problem, you would not see that as an answer. Okay, does that make sense? Okay, I have a person puzzle for you. It has 8 problems. Do we feel reasonable about 8 problems? That seems okay? Okay, and then since we didn't get to do very many examples,